My name is Rob Sadowski. I work in the product organization on security and trust here at Google Cloud. We'll also have Eugene Liderman. He's going to speak later about devices, and I'll let him do his own introduction and publicity. Okay, so what are we going to cover today? Here's our agenda. To do this topic justice, I think first we need to describe what we mean by modern end-user computing. What's modern? Who are the users? This baseline understanding is really going to help us understand and think through what it takes to provide robust enterprise security in that environment. We're going to need to think about applications. We're going to need to think about users. We're going to need to think about devices. And securing each of these presents a unique set of challenges. But solving the overall challenge of modern end-user computing and how we make sure that that's secure and productive is going to require us to follow some basic good security principles. We're going to take a defense-in-depth approach. We're going to have a solution that encompasses protection at multiple layers, in every layer, in a much more holistic way. So let's get in and start with some context about the modern end-user computing environment, because it's the thing that's creating the security challenges and the opportunities that we're all facing today. So everyone hold up your phones. I know you were told to silence your phones. Yes, everyone has a phone. And how many of you are taking notes or doing something else on a laptop? Some people, right? So this is today's reality. This is what we're talking about in terms of modern end-user computing. We work wherever we are, even if we're in a movie theater, right, at a conference in San Francisco. How is this possible? Well, one, the access devices support it, right? We have always-on connectivity. We have really much more convenient form factors than lugging around a desktop or something like that. We have a decreasing dependence on fat client apps that have to work across multiple operating systems and things like that. And that means that you and your employees and the people that you work with, the users on these devices, can access your work apps, not just the consumer side apps that you're kind of consumerizing and using potentially for work stuff, but you can actually access the primary tools and apps you use to get your job done through a browser or a much more lightweight mobile client. Second, what we are accessing is increasingly not sitting in one of our own data centers, and that traditionally has created a lot of challenges around connectivity and doing that at scale. So much more of what we are accessing to get our primary work done is in the cloud, and therefore it's on a public network. And these networks are something to which we have pretty ubiquitous access. You came to this conference and just assumed that you'd have a pretty solid high bandwidth connection. Now that's mostly worked. If you were here last year, didn't work so well, but this year so far so good, right? So we all assumed that we were going to be able to do that, and that's great. But failing that, guess what? We have a backup. We have wireless connectivity on our phones, right? So we are always connected. And that creates a lot of opportunities, but potentially some challenges. So the technology is there, but why else have we embraced mobility so strongly? Because what we find is that when we do, it leads to increased productivity, increased collaboration, and reduced overhead. So, some of the data here is actually really, really compelling. There's been a 2-year Stanford study, 2 years, right? So it's not just, hey, do a quick survey, that showed a 13% increase in productivity when users work from home. Again, that's that modern end user model. Other research indicates that employee mobility leads to 30% better business processes, better following of processes, better redesigning things to work better, and 23% more productivity. These are real significant gains. And that we find, and I think this is our own experience, that working from home reduces attrition, right? So retaining and keeping talent is so important in today's world. Anything we can do, and something with a lever like that, so important. The other thing is that these devices and this way of working allows us to communicate and work asynchronously. So kind of asynchronous communications that are facilitated by devices and cloud technology allow us to be more efficient. Web-based meetings are better planned and more apt to stay on message. I can't remember the last time I didn't have a web-based meeting or do things on conference calls, but more and more and more, we're getting more done in less time. The net is that modern communication and collaboration can increase productivity again, 25, 30+%, and increase employee satisfaction. And yes, usually when we talk about benefits, we go right to costs. And certainly there's an element of cost savings here, something like that. You look at what IBM does. They've been really public about how they have moved to essentially a remote workforce, folks that work and are enabled by these technologies, and they've saved more than $50 million by making many of their positions remote. So while cost savings probably isn't the primary benefit in a lot of cases, it is certainly part of the equation. But this new model of working means we are also faced with a new set of risks, right? Security professionals, when you say, okay, what's going on now? What are you concerned about? They find a lot of challenges in defending against threats to mobile devices. And this survey, ranks them the #1 hardest enterprise asset to defend, right? There's a lot of user intervention. There's a lot of user control there, right? So that's a pretty strong statement, the #1 or most difficult asset to defend. And 3/4 of organizations report that they've suffered some sort of breach or incident as a result of a mobile security issue. So these aren't likely to be the big mega breaches where you aren't storing hundreds of millions of records on a mobile device. But nevertheless, when we have regulations like GDPR, where we have to, disclose when, personal information is disclosed, that type of information does get onto devices. And so this is an increasing concern, even if it isn't the large mega catastrophic breach that it may be. It's all still very, very important. So how do we enable the business? How do we unleash that productivity without increasing or creating unnecessary security risk? Well, to do that, we need a strategy that thinks through and understands the whole stack that we are using to deliver IT services in this new world. And as I said before, we have to take a defense in-depth approach. It's not just about the device, although that's really important. It starts at the infrastructure. We have to think about the apps that are on these devices and the apps that we are delivering information through to these, to these workers. We have to think about the users and how we establish their identity. We have to think, again, about the devices. So we need to build protection into every layer and take advantage of the controls that are there so we can build end-to-end security. So what I'd like to do now is kind of walk through what we can do in each layer and what specifically you can get from Google Cloud, what we're doing in many of these in each. So perhaps now, but certainly going forward, the services that workers access to do their jobs will be largely based in the cloud, right? And while this used to be seen as a source of risk, it's now seen, cloud infrastructure is now seen as a security enabler or a strength. Gartner says that over the next several years, workloads that leverage cloud infrastructure, right, whatever those workloads are, will suffer 60% fewer incidents than those in traditional data centers. That is a really, really strong, compelling statement. And I think that, the experience that people have in operating the cloud bears this out. Another study that I cited in another talk this week is that going from last year to this year of organizations that are putting applications in the cloud, 90+% of them trust the cloud more, right? It's that repeated positive experience that they are getting, that they are realizing that the cloud infrastructure is not part of the security problem, it's part of the solution, right? So how do we leverage that in this modern world to increase security? So the foundational layer of our stack, right? That's what I want you to take away. The infrastructure is getting more secure over time. And in Google Cloud, the infrastructure layer that we provide offers many unique benefits that you can take advantage of. So we do a lot of security by default, right? When data is stored or services that run on our cloud, when you put data in there, all of that data is encrypted at rest by default without any without any interaction required by you on behalf of the customer, or you as a customer. The second thing that we do, or the second thing I want to highlight, is that the worst thing that can happen is that someone is working remotely or working in the field and they can't get to the application. The size and scope of our network, as well as the protections we've built in by default, help organizations mitigate potential network and DDoS attacks really, really well. The other thing is that as you're deploying apps for those users to work on, again, downtime really impacts them. We do all the infrastructure patching automatically. So not only do you get the benefits of a constantly updated infrastructure that's not subject to vulnerabilities, but we don't have to take downtime. And this was a particular particularly great feature when the processor vulnerabilities around Spectre and Meltdown that Google researchers actually found needed to be fixed. So across our whole fleet, we were able to patch that in Google Cloud without taking any downtime, which is not the case on many other services. The second thing is that we are building on, or you're building on, a purpose-built infrastructure. So we design all the way from the chip up to the chiller in the data center our own infrastructure. That's the chips that go in the servers themselves, the storage, the networking gear, all of that. We have a private global network, and so when we are accessing services on that, traffic that gets off the public internet and gets on that network is much less likely to be intercepted or manipulated. And again, I talked a little bit about the chip side of things. We have hardware-based tamper protection to make sure that the infrastructure that your app, services, and data sits on is always in a state that we know exactly what is running there at all times. And then we'll get into this a little bit later on. There's a lot of proprietary controls and expertise that are embedded here that you can take advantage of. So we'll talk a little bit about the way that services in G Suite like Gmail do things like phishing and protection against malicious email. We talk about the easy way you can implement strong authentication with security keys and some of the things we do there. We talk about the ways we can prevent data exfiltration from certain services with things like VPC service controls. And just this week, we introduced a set of what we call user protection services that help deal with risk of suspicious or malicious URLs and applications that look at, again, other ways to do phishing defense and protect applications against abuse by bots or other things like that. And the other thing that we do from a security perspective that is really important as the operator or administrator of the infrastructure like this is we provide a tremendous amount of visibility and transparency. So you maybe heard Urs in the keynote today talk about access transparency, where you can understand if any cloud administrators are ever accessing your data in the course of doing support and things like that. So you can feel confident that what you are doing is robust. We also give a lot of visibility into just overall operations, with our Cloud Security Command Center on GCP and our Security Center within G Suite to really highlight where are the particular areas of security risk. So what I want to, again, to take away is that there's a really robust foundation for building the apps and delivering the services that these modern end users, these mobile users need. The other thing is that building on an infrastructure like this, you get the assurance that not only the infrastructure, but the services that sit on top are validated against some of the most rigorous global security and privacy standards, like the ISO 27000 series. And we know that as you adopt this infrastructure foundation, you may want to bring some of your existing security tools with you. So we have an extensive ecosystem of security partners that deliver their capabilities on cloud platforms. And on our cloud platform, that runs the gamut from things like identity and access management solutions, monitoring solutions, GRC solutions, endpoint security, which I'll talk about in a few slides here. Cloud access security brokers, which are really important for some organizations in getting the level of control that they want in this perimeterless world. So you can preserve existing investment things like your endpoint protection platforms and still leverage those as you build on our cloud infrastructure. So hopefully you take away why cloud, that foundation in many ways does or will underpin what we're doing around modern end user computing. So now let's turn our attention to some of the layers of the stack we more commonly associate with these challenges, about the apps, about the users, and about the devices. So the layer above the infrastructure is the application layer, and these can be applications that you build or deploy in the cloud yourself, or they can be SaaS apps or other services from a third party. But regardless, we need to think about what are the features and what are capabilities that we're looking for. So in terms of what we offer and the way we think about some of this within Google Cloud, G Suite offers many security benefits that are really attuned to the needs of this modern workforce, much more collaborative and things like that. First, G Suite is very, we have these core guiding principles around being proactive, about being intelligent, making things simple, and building compliance in. So, in terms of being proactive, what we are looking to do is automatically block many of the threats that target cloud workers, especially in email. I think we're all aware that email is the #1 app, the most critical app for these mobile, more modern workers. And G Suite has 99.9% plus accuracy in blocking spam, in blocking malicious email, in dealing with business email compromise type scams. All of the outbound email is checked automatically if you turn on things like DLP for sensitive information, and so that can be automatically flagged, again, potentially eliminating sources of risk or data exposure. And there are built-in defenses as email comes in against attachments carrying ransomware and other malware that can get on the device that users are using and affect the security there, right? So today, we announced some new advances in G Suite in this area around stronger phishing and malware protection and some sandboxing technology that goes even further in allowing us to deal with more sophisticated malware. So we constantly keep pushing and in trying to advance the state of the art. The other thing that we think about is, again, this notion of intelligence and being proactive. We want to help stop threats to this workforce, to these devices before they turn into damaging incidents. And the intelligence that's in G Suite can help surface the most worrisome security concerns like potential device compromises. We have a part of our G Suite Security Center has a whole specific section that allows you to look at your device footprint and understand, is there a potential compromise there? Which users is it affecting, so you can deal with this? And we try to do this without sending you constant notifications about less important issues that are less impactful. And again, we strive to make these simple. We have this philosophy that security tools are only useful if you actually use them, if you actually deploy them. And so if they're too difficult or too complicated, they're of limited use. We're always trying to give admins simpler, more streamlined ways to deploy this. Make a lot of the things available, again, by default, like I talked about, and make them work out of the box with the right configurations right at your fingertips. So now when I mention an application security layer, how many people actually thought about browsers? Maybe some of you, but perhaps not many of you. The fact is, many, if not the majority of corporate apps are or will be delivered in browsers, even up to productivity things. Like think of what we do with G Suite. Think of the sophistication we get in Docs and Sheets and other things like that, or some of the other productivity suites. It's an essential, the browser really is an essential part of that application layer that we need to have confidence in the security of. And Chrome Browser for Enterprise designs in many security features, right? We think of that in 3 broad areas. We try to make it safe as much as possible by design, so to build those protections in. Here again, just like we're describing a multi-layered approach, Chrome takes that same multi-layered approach in the browser itself, and we try to do many, many things to keep ahead of the threat landscape that targets the end user environment. So in terms of being safe by design, we employ technologies like safe browsing, which protects from a range of malware, phishing, and social engineering attacks, the sites that might be able to steal passwords or infect machines that would affect those users. This is a constantly updated database as we crawl the web of what we perceive or what we see as potentially malicious sites, and we'll provide warnings to users before they navigate to those. So again, it gets that distributed notion of warning or control out to users wherever they may be. Chrome automatically updates, right? This is so important for this modern mobile workforce. If you're not in the office, if you're not doing updates, if IT staff and team and desktop support staff is not touching that on a regular basis where they can do updates, we have to constantly update the OS, the application software, and all those other pieces, because we know that vulnerabilities get exploited very rapidly. The fact that cloud-based services automatically update and Chrome browser especially automatically automatically, updates is really particularly important to make sure that the users have the latest security features and fixes without requiring any intervention, right? Sandboxing is another thing in terms of design that is very, very useful in terms of the Chrome security model. It helps prevent malware from installing itself on devices, reduces the severity and impact of certain vulnerabilities that might be exploited. It also works, again, to prevent eavesdropping or other intercept of communications as the browser accesses websites. So it uses network security features like strict transport security, things like public key pinning, things like verification of root CAs to make sure, so building on what we do at Google around certificate of transparency, in doing things like mixed script blocking. So there's a lot of things, or a lot of potential ways that a browser can be exploited, but the design of Chrome tries to neutralize or make many of those much less, or make itself much less susceptible to those type of techniques. And Chrome really works to stay ahead of threats. There's a public commitment to releasing a fix for any critical security vulnerability in under 60 days. And on average, those vulnerabilities are fixed within 30 days. And even when necessary, we think that something is particularly severe, we've pushed fixes in under 24 hours. So the team is really always actively working to find and fix vulnerabilities before they affect users. And that's that point about trying to stay and working to stay one step ahead of potential adversaries. So that's the app layer. But what about users? How should we think about protecting this broad and increasingly growing user community? And I think that's the first point I want to make. The notion of who is a user in this more modern world is evolving. It's not just employees. It goes beyond that. It's vendors, it's partners, it's contractors, it's customers. And all of those different user constituencies require different levels of access to different information, to different data sources, to different applications from different places on different devices, right? Think of that matrix. It's complicated. How can we help deal with some of those challenges? So back in 2011, Google came up with a new approach for access management, dealing with these types of challenges. We called it Beyond Corp. And this enterprise security model started off as an internal Google initiative to say that, hey, we want to enable any of our employees to work anywhere, essentially, in the world from untrusted networks, right? We want to rely on the internet, not have to rely on a VPN, which can be very complex. This actually sounds really close to this description of modern end-user computing that I talked about at the beginning. So what Beyond Corp aims to do is shift the access controls being solely based at the network layer and around the perimeter to switch that much more into, or make it much more about context, about the user, about the device, and what they're accessing, and arbit decisions based on that, right? Don't just make an assumption about trusting the network, because we know that these modern end users are not going to be working from inside the office where we have that presumption of trust. And because of the trends that we've been speaking about, there's been tremendous support for an idea like this. If any of you were at kind of the RSA security conference over the past month, I think the biggest theme that came out for me was this idea around how do we implement zero trust networking? How do we take models like Beyond Corp and actually make them real? Because conceptually, they address a lot of the challenges that we've been talking about. Here's a great quote from Steve Pugh. He's at a company called Ionic now, who's a Google partner, but he used to be in the office of the CTO in various branches of the military and in the White House. And he says, this vision is really the future of enterprise IT, right? This is the modern world that we are dealing with. It's a model that builds on zero trust and combined with best-of-breed ideas from the community. So we've tried to adapt and see what's the challenges in terms of implementation and adjust and go on. And so at Google Cloud, we've been working really hard over the past year or so to help you implement a similar type model, implement this Beyond Corp model for your users through a set of products and capabilities on our platform and in our services, and we put this under the umbrella of what we call context-aware access. We want to enable you to make context-aware access decisions for any type of user to any type of resource within cloud. And what we do here is we take inputs from the user side, and we take input from the device side, and then we incorporate a whole range of contextual factors like IP address, like location, like the time of day, like the length of the session. We run those through a rules engine, right, that we call Access Context Manager, and we leverage a number of enforcement points so that we can control access for remote users to the diverse set of resources that they're looking to get access to. So whether those are web apps, whether those are virtual machines, whether those are other services or resources on GCP, whether those are APIs, whether that's G Suite, whether that's generic SaaS apps, right? Any of those, we want to be able to set precise access policies and rules that take into account the environment that users are finding themselves in. And a key enabler for this that Google Cloud is providing is our cloud identity solution. So it's our repository for user information that we have to understand. It's our identity as a service solution, our IDaaS solution, that offers one single place to manage users, apps, and devices. It allows you to get this context-aware access capability for G Suite and SaaS apps. It allows you, to help with the account hijacking side of things, to implement strong two-factor authentication with security keys and other methods to prevent account takeovers. It does a lot of account protection in the background based on Google's intelligence and signals and what we do to protect the billions of accounts that access our services. It offers, this is really important, integrated unified endpoint management, both from a lightweight perspective and also more in-depth if you want to do that, so to get that touch. It offers a dashboard that I made a little bit of mention of in terms of highlighting where the biggest sources of risk and what's going on across these different identities. And this is a service that is now today used by customers to manage more than 100 million users and over 55 million devices. So, this is one of the kind of almost best kept secrets inside Google Cloud, and really is a fundamental underpinning of how we are enabling and how we are helping people to work in this new modern environment. So, what I wanted to do is kind of stop talking and do a little bit of a demo to show you how this actually might work, to show you how these different layers, from the infrastructure layer to the app layer to the user protection layer, how all these can work in concert, and how implementing context-aware access for your modern end users actually looks like. So here's a business scenario that poses a lot of the challenges that we face dealing with this modern end user computing environment. So we have a company called ZocKicks. They work with a company called Acme. So already we see kind of the complexity and the collaborative nature of work. And so in this scenario, the ZocKicks HR department is going to hire or bring on some contractors from Acme to help with a few things. So they are going to need access to the internal HR system. Well, there are no notion of an internal system. We want to make that available as a service, so that users can access it theoretically from wherever they are. But the security policies that they have in place require some very specific things for contractors to access them. They should use strong authentication in every case. And in this particular case for HR, we actually aren't going to allow you to work from anywhere. You must be on or accessing this from a company office. And so the IT department, while this may have been a daunting challenge in the past, it's absolutely the type of thing we have to do in today's world, in today's environment. So their IT department says, consider it done to both HR and security. So how are they going to do that? Well, they're going to deploy this HR application on Google Cloud. They're going to define a VPC, Virtual Private Cloud Network, for their app, and they're going to stand it up on Google Compute Engine. And then they're going to set up cloud load balancing right at the edge for ingress from the internet. And they're going to use the Cloud Identity Aware Proxy, which is integrated right into cloud load balancing, to front-end the app. Okay, so those are all the features that they have that take advantage of what's there. And the Identity Aware Proxy IP is going to draw on user information that they maintain in Cloud Identity it's going to rely on device status from endpoint verification in Chrome browser, and the Access Context Manager is going to be used to define their access policy. So this is why I talked about the cloud infrastructure layer first in talking about modern end user computing. These key enabling services that we need to enable us to work the way we want are part of the infrastructure where the app and the data and the mobile users that they're going to access where all this lives. So let's take a look at what this looks like. The first thing I'm going to do is I'm going to set up the access policy that restricts access to the office for this app for contractors. And because I fear the demagogues a little bit in a movie theater and I respect your time, I actually recorded this earlier. So what I'm going to do is I'm going to go, what I did is I go to the GCP console, and I'm going to go to Security and go to Access Context Manager. So really easy to do right here in the console. And you can see, as we select this, you can see I have a whole set of existing policies here, but I want to go and define a new access level. And I'm going to call this from Acme Office, make it very descriptive. So type that in. Don't always type that fast. And then I'm going to add an attribute. And here, what I'm going to do is I'm going to specify an IT-based attribute, and I'm going to specify the IP range that corresponds to the internal office. Now, when I go ahead and save that really, really quickly, that is going to show up in my list over here. It says that my level is created. And down here, I can see that new policy is in my list of Access Context Manager policies. All right, so far, so good. So next, I'm going to go in and I'm going to configure the identity-aware proxy. So I'm going to go in, I'm going to pick my project, I'm going to click on the service, the back-end service that connects to the HR app, and then I'm going to go in, I'm going to add members, which allows me to say what group of users that this policy is going to apply to. Remember, we're identity-aware, right? That's the key point of this. And so I'm going to add in the group name, which includes all the contractors. I'm going to select the policy that we just defined. There it is, scroll down from the Acme office, and I'm going to save all of this. It's going to instantiate, it's going to get loaded along with the other policies that you see there on the right. And so that's the admin experience. It's really straightforward, right? So this might have seemed, wow, this is really complex, but it's actually fairly simple to step through. All right, now let's flip it over and take a look at the user experience. So we're in a browser. Because it's a modern app for an end user, for a modern end user, and look, I'm on the Wi-Fi inside of Acme Corp. So we're going to hit the URL for the HR app. Our user is going to be asked to sign in. Okay, we do that. We put in our password. And now, because we have that policy, we're going to be asked to authenticate with a security key, again, according to our policy. And since we've satisfied all the requirements, we're in the office, we're authenticated with a security key, we can get in and get access to that app. So now let's change things up a little bit further and see what happens when we don't meet the conditions. So now we're working remotely. You can see that we go on and we're actually on Starbucks public Wi-Fi out there on 3rd Street. And so we're going to go in and we're URL for the HR app, just like we did before. Hopefully my mic does not die while I go through this. I only have to talk for another minute or two here, so we're hoping. And we're asked to sign in with the security key, but what happens now? The login fails because we didn't meet all of the requirements in the policy. So here, look, we have multiple layers. We have the infrastructure, we have the app, we have the user, we have protection that's working at every level, working in concert to provide the security and ease of use for the modern end user and the way they work. And one last thing, we didn't talk too much about devices, although that's one way you can define policies. And device trust is a really, really key input for this context-aware access model. We know that we can get device context from Chrome browser via an extension, but we know many organizations already have mobile management solutions in place that they're using to secure this mobile workforce. So today, we announced something we called our Beyond Corp Alliance. And what it is a partnership with a number of the key endpoint and mobile security vendors who can help provide device status data back into Google Cloud from their products. So you can use the data that's coming from these platforms to make better access decisions on whether or not that product says the device is in a safe state or not. So it's great validation, I think, for our vision and approach of what we're doing here from other leaders in the end user computing security space. And that's really a great segue into devices. And so the final layer we want to talk about is the device. And there's a bunch here we want to go through, so I'm going to turn that over to Eugene.
Really quickly diving in, It's so hard to see everybody. The light is shining so bright. It's like nobody's actually here. So when it comes to devices, taking a step back about devices for a second, obviously, Google has Chrome OS and Android OS, and we work with a variety of ecosystem partners, device manufacturers. Obviously, we have our own devices, but there's a huge, broad ecosystem of partners out there. And one of the things that's really important when it comes to both Android OS and Chrome OS is Google's commitment to transparency and openness, right? I think Rob touched on it a little bit earlier. Obviously, Android is open source. Chrome OS is built on Chromium, which is open source. Anybody can go see the contributions that we make, the changes that we make. We blog about new features as they come out. We publish in-depth white papers and reviews. We actually just published an Android security and privacy journal review a couple weeks back. And we also publish transparency reports to highlight the state of the ecosystem. So we have an Android ecosystem transparency report. We also have a Chrome Safe Browsing transparency report. So it's just part of our ethos. We try to be transparent with everything we do when it comes to these mobile operating systems. So speaking of security, I think Rob touched on this before. Obviously, you hear it a lot. It's all about secure by design. Security is a foundational principle. We have dedicated security teams, right, for both Chrome OS and Android OS. We're continually improving security, always adding additional hardware-based security features, anti-exploitation techniques, and just implementing it at every layer. You've probably heard, he said defense in depth, layered security, the onion model, whatever analogy you want to use. We're constantly beefing up our security for these operating systems. And so just to highlight some of the, at a high level, the pillars, or not pillars, but the stack, obviously, it's, like I mentioned, hardware-based security. You got, we obviously use the Linux kernel, so we implement a lot of security around sandboxing, app security, security for the data on the devices. And one of the things that's interesting about having a broad ecosystem of partners is obviously, coming up with design principles and requirements, and then having to making sure that these partners are actually implementing everything done. So on the Android side, we have the compatibility definition document that states what must be implemented by our partners, and then they go through various conformance tests, or like CTS, VTS, STS, to make sure that they conform and these devices ship to our standards. So starting with hardware-backed security, I think Rob mentioned it a little bit on the GCP side. Of course, we want to make sure that when the device boots up, it boots into a verified state. So we have verified boot. Verified boot, for anybody that doesn't know, it basically verifies the boot up process cryptographically at every stage. So if something bad happens during the boot process, it will alert the user and react from there. So some examples for verified boot and why it's necessary, of course, obviously malware is a universal risk. And the first thing malware will try to do is modify the system partition and persist. And so with verified boot, when the device boots up, if something bad happens, it notifies the user. And since these operating systems are modern, they actually have two copies of the OS. So what it will do is if the primary copy is in a known bad state, it will try to roll back to the other copy if it's the same version, right? So in terms of additional platform security features that are hardware-based, so of course, both OSs have full on-device encryption. They actually use file-based encryption, so full data at rest. They both leverage the hardware-based security for key generation and key storage. They both, of course, benefit from using the Linux kernel. And so they're both implemented with mandatory access control, where everything is broken down in specific subcomponents, kind of protecting one from another, making sure that if something does bad happen, it doesn't go across the entire OS. And then, of course, as Rob touched earlier, with sandboxing, the same thing happens on the device OSs. Of course, we implement application sandboxing for both OSs, where every single app is isolated. It has its own resources, such as processing, memory, and storage, and one cannot go and eavesdrop on one another, right? And the last thing is, you'll see over the last couple of years, both OSs have heavily added additional anti-exploitation techniques and methods. So address space layout randomization in both the user space and the kernel, data execution prevention, control flow integrity. The whole mission there is that the more of these techniques we can apply, obviously these are large OSs, hundreds of thousands, millions of lines of code. So if we can implement additional methodologies like this, we basically can help prevent a potential bug or vulnerability from becoming exploitable and compromising the entire operating system. So the next big thing, and I think Rob touched on it a little bit on how easy it is to update on the cloud side. On the mobile device side, patching has also improved. Obviously, everybody knows Patch Tuesdays and all those good examples. On Chrome OS and Android OS, we provide a nice cadence for patches. For Chrome OS, security patches come out every 3 weeks, 2 to 3 weeks. For Android, we provide monthly security bulletins to the ecosystem. The real benefit there is that we've decoupled security patches or security updates from feature updates. So they're smaller, easier to take. And it's also, the goal is to make sure that users have an easy way of adopting these updates. And so both OSs leverage seamless updates. And what that means is, since both OSs have 2 copies of the OS on the device, what happens is when the user is idle on the device is just idle and not being used, the updates download in the background. And when it's ready to install, it notifies the user. So all the user has to do is hit restart, and all of a sudden, the device reboots, and you're now running the latest update. And behind the scenes, what really happens is, as the OS reboots, it now switches to that secondary copy, it verifies it, and if something bad happens, the nice thing is it reverts back to the last known good copy. So there's no risk of losing data or information. On the Android side, obviously, since your device, you walk around with your device, it's not always plugged into power and you're using it. We're a little bit more gentle in the way we do these updates. So we obviously wait until the device is plugged in, you're on Wi-Fi, and it's sitting there idle, so it doesn't impact your usage of the device. Of course, everybody here is probably familiar with the Google Play Store. Google Play Store is what all Android devices, all GMS devices have for access to apps. That's our central app repository. There's obviously millions of apps in the Play Store. A lot of people don't know is that Chrome OS also supports Android apps, and it also has the Play Store. And so for an enterprise deployment, you can actually deploy these apps through what we call Managed Google Play. This is where you can allow IT to provide a curated experience for your applications, so you can decide what applications you want to deploy. They have that nice view of just those approved applications. You can push them automatically down to the device. You can control update policies. You can actually leverage manage app configurations, where if an app developer supports various configurations, obviously every environment is different. This allows them to customize certain things and make changes as they see fit. And what's really neat, especially on the Android side, is that since we do support multiple management models with fully managed and BYOD with a work profile, you can actually end up having a personal instance of Play where the user can download whatever apps they choose, and then in the work profile, which is basically a separate Linux user on the device, although it's in the same user experience, you end up having a separate managed Google Play that IT can curate, and there's that perfect separation so that IT's not overreaching onto the personal side for the user and their device. So obviously, I think I touched earlier, malware is a universal risk, right? And so Rob touched on Chrome Safe Browsing, which is widely used across Chrome OS and Android. The other thing that we have is Google Play Protect, which is our built-in anti-malware solution. It's actually the largest or most widely used anti-malware solution out there. It basically scans over 50 billion apps across 2 billion devices every single day. On the back end, it also analyzes and reanalyzes about 500,000 apps every single day. It leverages machine learning, artificial intelligence, static analysis, dynamic analysis, heuristics, heat maps, and many other techniques. And it works for both off-play and on-play, as well as offline. So even if the device is not connected, it's still scanning and remediating. And if it finds a potentially harmful application, which is what we on the Android security and privacy side refer analogous to malware, it can remediate that and remove it off the device or notify the user and so forth. In terms of, like I had mentioned earlier, we talk about transparency and openness. We publish an annual year in review, which we just published 2 weeks ago. And this year, the likelihood of you have a higher likelihood of dying in a bathtub than you do of installing a potentially harmful application from the Play Store. I know, very morbid. Nobody likes that stat for some reason. But I still went with it. So this is something new that we just added. We just announced this today. So again, Rob touched on hardware security keys. Of course, G Suite supports this. A lot of third-party solutions as well support this. And as of today, you can actually use your Android phone as a security key. So it's basically Android Nougat and above. And so that's 1 billion plus devices that have the ability to now leverage this functionality. On all of those devices, it actually does use hardware-based security because it's using the trusted execution environment to store those keys. And then specifically on Pixel 3 devices that have the Titan M chip, it actually leverages that discrete tamper-resistant hardware with the Strongbox API. And these, of course, work over Bluetooth with your existing laptops and desktops. So One of the other things that, kind of the key things that we focus on is measurable security. We like to set benchmarks. We like to see how we do. And so this is actually something that Gartner publishes every year. They have a new report actually coming out very soon. So this is the previous report, but this is the mobile OS comparison report. It's pretty comprehensive. There's about 28 categories, and it focuses on platform security features like network security, OS updates, app updates, and then specific enterprise requirements around policy management, authentication controls, key management, and so forth. And what you'll see highlighted there in the orange box, the ones that scored the highest in this report were all Android devices. So Android Oreo, the Pixel 2 on Android Oreo, and a Samsung device on Android Oreo. In fact, the Pixel 2 received a high rating in 24 out of 28 categories. And comparatively, if you look at some of the other OSs, they scored half of that. So to close, Google Cloud with GCP, G Suite, Chrome, and Android help you securely enable, this is the last slide that I never could get right, securely enable modern end-user computing with security capabilities from the device to the data center. We can help keep your enterprises secure and your users productive. Thank you.